Hello, welcome back to Cracking the Cryptic, and today we are looking at a puzzle that I'll discuss it in a minute. I'm very interested in the setup to this. Two aspects, at least, interest me a lot. First of all, don't forget to check out Patreon. At the start of next month, we will be releasing Alice in Sudoku Land, and it's a great hunt. Not too difficult. Is it 9 puzzles? I can't remember exactly. It may be more, maybe 11. It's somewhere around there. It's really good, and do join us on Patreon and get that. We've also put out on Patreon today the solution videos by Glum Hippo to the Glum Hippo Hunt. Well done to Caitlin for winning the prize for that. Loads going on the channel. What else have we got? We've got... I haven't heard from John Halpin for a while about his creating crosswords with celebrities, but the Times Monthly Club Special crossword has gone up on Patreon as well. That's my monthly solve of an extremely difficult puzzle. And to call it a solve this month might be slightly over-egging what I achieved. But you can find the solution during the video if you watch it all. It's about an hour. Now, we've had some very long puzzles on the channel, including mine yesterday, Simon's 2.5-hour Fistamafel battle earlier in the week. I've no idea about this puzzle and whether it will be that long. Oh, I would mention our merchandise and our apps as well. They're all on the links under the video along with the Discord server. But this puzzle, so Sander Molenbeek wrote to us to say that it had the idea of creating a puzzle based on a set of dominoes. And that he'd then extended the set of dominoes to be from using the digits 1 to 6 up to 1 to 9. Well, I don't think you're the first, Sander. As a child, I had a set of dominoes that were 1 to 9 from Denmark, and I got the impression that in many countries that was actually the standard set of dominoes. So I don't think you had to reinvent the wheel there. The wheel existed. It's just applying it. In fact, when I was reading the email, I was thinking, oh, well, surely you could use more than the set of 1 to 6. You could use the set of 1 to 9, if anybody could ever fit them into a grid. Well, I think Sander has fitted them into the grid, because the rules are very simply, normal Sudoku rules apply. Each cage contains a unique pair of digits. Isn't that a brilliant rule set? The colouring in the grid is unnecessary. That is just there to make it clearer where the cages are. They're all obviously 2x1 cages. Now, they're done in 3 colours, and this is Sander's colouring pattern. I assume, obviously I'm aware of the 4-colour theorem, which states that any 2D divided area only needs 4 colours. I wonder if any mathematicians can just tell me very simply why it's clear, as my brain thinks it is, that any layout of dominoes like this on a square grid would only ever need 3 colours maximum. It feels right, because somehow in my brain the dominoes can't get round and require the 4th colour, but I don't know how to express that. But we have so many brilliant mathematicians watching that I'm sure somebody can express that for me. Anyway, Sander is obviously aware of it and has therefore decorated the grid in 3 colours. His name, actually, I don't think we've featured Sander on the channel before. His name reads like somebody spelling out how to say a Dutch name for me, Molenbeek. You know, I'd kind of imagine he was Muhlenbijk or something, and this is the pronunciation guide, but that's his name. So there we go. Anyway, let's have a go at this. I don't know, there's a lot of given digits. There's as many as you might get in a classic Sudoku. So I'm hoping it's not too hard, but I have no idea. I'm going to restart my clock and let's get cracking. So what I'm hoping is not going to happen is that we're going to have to make a huge grid of the possible dominoes off this grid, and check off the ones we've filled in. Now, the first thing I want to just think about briefly is this the full set of 1x9 dominoes? I could calculate how many cells that would be. No, the simple thing is, how many dominoes are there that have a 9 on? Oh, well, obviously there's no double 9. Right, we can rule that out. How many other dominoes? Because it can't exist in this puzzle. So it's not a full set of dominoes, as it were. But it's probably a full set with no doubles, I think. How many would have a 9 on that weren't double 9? Well, you could put the other digits 1 to 8 on. So there would be 8 9 dominoes. Now, I'm not going to add up how many there are with 8 9s, 7 8s that aren't 9s, 6 of the next, 5 of the next, and so on, because that's boring. What I'm going to do instead is say, for the 9 9s in this grid, only one of them would not be in a domino. And that must apply to every digit, and therefore the number of white digits we have not in dominoes is probably 9. It is, and is the full set of the digits from 1 to 9. Each of those is where they don't appear in a domino. So, what I've finally established, and I could have done it much quicker, I'm sure, is that every possible domino that isn't a double is in this grid. And hats off to Sander for including them. That's really interesting. Now, I'm going to try and do some ordinary Sudoku. So 9 and 9. There is a 9 in this domino. It must go with 1, 2, 7 or 8. But we've had a 9, 7 already. So the 9 here goes with 1, 2 or 8. Actually, my pencil marking style is quite well adapted. What I'm doing is 9 in the corner means there must be a 9 in one of these 2 cells in this box. And so I will be able to tell as we go around the puzzle that, for instance, in this domino, it's made up of 9 with one of the other candidate numbers. That's quite useful. 4, 4. So there's a 4 in this one. We know where it goes by Sudoku. Now, what does it go with? 7, 2, 5, 9, 4, 3, 6. Either 1 or 8. They're the only digits by Sudoku that are possible. We haven't got a 4, 1 or a 4, 8 in the grid already, so I'll leave those. There's a 7 in one of these cells. 2, don't know. Ah, this is good. Look, this is a naked pair, that rare beast. It sees this pair of cells, see 9, 8, 3, 4, 5 in the row, and 2, 7 in the box. So they're a 1, 6 pair, and we've had a 2, 1 domino, I can see. So that is a 2, 6 domino. That digit is a 1. We need 2 and 7 at the ends of the row. I can't see that either of those are replicated. 9 is going to be in one of these 2 cells and not in the 9, 7 domino. So 9 goes there. Now we've had the 9, 1 domino, and I'm taking that possibility out of this bottom left. That is 4 or 8 by Sudoku. We haven't got any proof of that. This includes a 5 and either 4 or 8. Not sure what that is. 2, 9, 7, 5, 3. Yeah, it's worth remembering the white set is a group of the digits 1 to 9 by virtue of that calculation we did earlier. And where does 4 go in it? In this box, definitely, not there. So one of those 2. Oh, well, that's really handy. Look, that 4 is ruling out those 2 from being a 4. This one is ruling out those 3. There can only be 8 4s on dominoes, so one of them has to be in a white cell. That one is ruled out. So there's a 4 in one of those cells and no 4 in that domino, which therefore becomes a 5, 8 domino, and that becomes a 4. Which is interesting. They didn't expect that sort of deduction. 7, 2, 5, 9, 4. So we just need to go on. You know, I'm really hoping we won't need to do some dramatic elimination, but it is a new form of scanning we have to do here. There's a 4 in one of those 2 cells. I don't think 4, 1's been eliminated yet. There's a 9 in one of those 2. 9, 2 hasn't been eliminated as far as I can see. There's a 7 in one of those. This sort of scattershot approach could well be wrong for this puzzle. I'm in no doubt about that. But nonetheless, I'm still doing it. Right, there's a 1 in one of those. My goodness, there's a lot of candidates for 1-4 dominoes. It would be nice to know where it is. That is 3 or 8 by Sudoku. One of these is a 2. That's not very helpful. Ah, this has become a 1-4-6 triple. That is a naked 1. Why did I ever think that could be a 4? For some reason I can't see given digits very well. There we go. So that's all done. 9-7. This is a 9-7 pair. We know how they go in. This is 2-3-8. Now, are any of those combos already ruled out anywhere? Doesn't look like it. This is 4-5-6. Now, that feels a bit more like... Now, we can't have another... Well, that's not 4 by Sudoku. We couldn't have another one in white. In fact, the white set are now 1-4-9-8. We've got to get 2, 7, and 3 in. 2 is going to have to be in one of those. 7's in one of those, but I'm not pencil marking that because it goes across box boundaries and I would confuse myself. Let's keep an eye on that white set. 9s have become very fixed by Sudoku rules. There's an 8 definitely in one of those cells. Now, have we had 8-6 or 8-9? No, that's not an 8. 5-1-3. This has become an 8. Oh, I want a 4-1 domino, not to know that they're not. That is not 3 or 8. That's 2. That's 7. That's 2. Now the white cells 4, 2, 9, 1, 7, 8. That can't be 5, so it's 3 or 6. That could be any of them. Box 9, 2, 9, 4, 7, 8, 3. We can put a 6 there, 5 and 1. I'm not going to be unhappy if we get through this puzzle without actually having to tally up the dominoes. I'm just going to rely on Sander to have got them right then. Now it's down here that this is the sort of place it might be very useful if we've had a lot of 9 dominoes already. In fact, that is a 3 or an 8 now in that row as well. So what have we had? We've had 9-6, 9-1, 9-5, 9-7. Here, 9-2 or 8. There, 9-3 or 8, and they're not resolved. Bother. Okay. Oh, look, here, these are from, in this column, these are from 1-3-6, and that's forming a triple. So there must be a 7 in this. I think, let's just keep going like this. As I say, there may be other ways to do it, but this is the way I'm doing it. 4 with, 4 and 7 we've had, so that is 4 and 2. That's the sort of thing I was looking for. And that fixes all of those. That's going to be helpful, surely. So, we've had a 5-6 here, so that's not a 6. This is from 3 or 6 in the column. What about 7s? We haven't had that many. 7-1, 7-6, 7-4, 7-9. That can't be 7-2 or 7-3. So that is a 5 or an 8. 2, 9, 7, 4, 5, 6. These, that is 3 or 8, and this is 1. Right, have we had 1-3 or 1-8 anywhere? Yes, we've had 1-3 down there, so that's an 8. That fixes a lot of these cells. Okay, maybe that's all for there. Now, in this column, we need to use 3, 5, 6, and 7. We've had a 7-6. That's all bother. Okay, let's look at, what do we look at? This. We've got a 7-6. That didn't resolve that. 3, 1, 6, 4. We've had quite a lot of 4s. 4-2, 4-8, 4-3, 4-7. And this can't be 1 or 6, so it's 5 or 9. 1, 6, 5 or 9 here as well. 1, 5 or 6. Oh, that can't be a 5 in the box, so that's a 9. 4, 9 is done. Oh, so we've got a lot of the 9s now. 9, 4, 9, 7, 9, 1, 9, 5. That's 4, 7, 1, 5 gone. And 6. And 8. So it's 2, 3, and 7 left to combine with 9. And 3 is done. So we need a 9, 2 and a 9, 7 with the remaining 9s. One of them is there by Sudoku. Should have spotted that. That's the 9, 2. And we've done 9, 7. That's all the 9s in the grid. Hurrah. And all filled up in their dominoes. 8, 8. That's an 8 by Sudoku. Now that's 5 or 7. So this is either 7, 5 or 7, 2. I can't see that either of those are gone. But this is 5 or 7 by Sudoku. Right. So actually that's very straightforward. 5 there. Has 5. Yeah, 5, 6 has gone. So that's a 3. That's a 6. We can finish off the white cells. I think we're going to finish off the puzzle. This hasn't been too hard. And I think there were enough clues provided that seemed the likely outcome. What I am glad about is it hasn't been too admin-y. Like, there's been a bit of extra scanning to do to make it go fast, but that's really all. Oh, that is not a 2. 5 and 7. There we go. Now, 1, 7, 8, 2, 9, 3, 5. We've got 4 and 6 at the top. That was the 1, 4 finally. The last, not quite the last 4 we put in. There's the last 4. 3 and 2. And I think that's the answer. So, there we go. Yeah, I think that must be right. So, not too difficult at all. In fact, finished in 12 minutes and a few seconds. I suspect, Sander, you could withdraw quite a number of given digits and make that harder and much more fiddly. In many ways, I'm very glad you didn't. And I really like the theory idea, actually, about using a set of dominoes. I wonder how many ways there are of putting a set of 1 to 9 dominoes in the grid. That's not something I'm asking mathematicians to look into. That's too difficult. Thank you very much, as always, for watching us on the channel. Hope to see you soon again. Bye for now.